Alright, we're going to determine the possible number of positive real zeros, negative real zeros, and imaginary zeros for the function. Alright, so Descartes said we could do this by noticing the change of signs. So there's no change here at the beginning. I have a plus out here. No change there. But when I go from plus to negative, that's a change. And when I go from negative to plus, that's a change. And when I go from plus to negative, that's a change. So I'm saying that there are three possible positive real zeros. May not be, but by the way, it makes sense. I have x to the fifth, so I have three. I mean, they could have all been positive possibilities, but the most I can have is three, or the other possibility is that I have one positive, okay? I might not have any, but remember that if I have a couple imaginary that get in there, they have to come in pairs. The irrational have to come in pairs. So if I do happen to have other things, they're going to take me out by twos. So I either have three or one, or maybe none at all, as far as positive goes. And then for the negative, what I'm going to do is I'm going to put in negative 1. I'm just going to do this in my mind, and I say negative 1 to the fifth power. What's that going to be? That's going to be negative 1. And when I raise it to the fourth power, it's going to be positive 1. And when we raise it to the third power, it's negative, but there's a negative out in front, so I'm going to say plus. And then I square it, and there's a negative out in front, so it's negative. And then I multiply it by positive 9, so it's negative 9. So I better put negative 1, I guess. Does it matter that I put the 1? And then I can't change the 15. Okay, so now let's see what we have here. We changed from negative to positive, and we changed from positive to negative, and then there were no changes after that. So there's a possibility of 2 negative, or of course there could be no negative, okay? And since this is a graph, that's x to the fifth, this is going somewhere, right? And it's a positive x to the fifth, so this is a graph that's, it might wiggle around a little bit, it might wiggle around a lot. I don't think so. Well, yeah, it could wiggle that many times. Let's just say it does that. It's going somewhere, and if it's 3 positive, it could all be 3 positive. But of course, there could be negative. So maybe I should have put an extra wiggle in there, because it's possible this thing crosses the x-axis 5 places. It could be 3 positive and 2 negative. Anyway, so let's think about the possibilities here. And of course, I'm going to put a picture up of the graph afterwards to see what actually happens here. So there could be positives, there could be negatives, and there could be imaginaries, okay? So if there are 3 of these, there could be 2 of those, and then there'd be no imaginary. And then for the positive, the other possibility would be that there's 3 positive, 0 negative, and 2 imaginary. And then let's see, what else possibilities? We got, as far as positive 1 goes, we could have, we're allowed to have 2, and so that would leave room for 2 imaginary. And then there could be 1, and we're allowed to have possibility of no negatives, so that'd be 4 imaginary. It's possible. It could just cross in one place, you realize. If the x-axis were down here, it'd just cross in one place, right? Okay. And then let's see, what else? Is there any other possibility? I think we covered them there. 3 and 2 and 3 and 0. Can't have 5. I'd like to have 5 positive roots, but that's not a possibility. Descartes said, nope, 3 is the best you can do. So I believe this is all my possibilities right here. And then I'll put up a picture of the graph and see what actually happened.